This is the screencast for section 7.1, example 3, calculating total distance traveled. So as we have spoken about before, including example 2 in this section, total distance is kind of like total area. So we are going to make the negative area positive and not use signed area like an integral. So if I want to find the total distance traveled by a particle whose velocity curve is this one, as you might imagine, it's going to be the antiderivative from 0 to 5, between 0 and 5 seconds, of the absolute value of v of t dt. Now, of course, that's easy to do in one step with our calculator, but I'm going to show you a little trick. Take the opportunity here to show you a little trick. First of all, if I'm trying to make this the absolute value, this negative area needs to turn positive. So I need to find that 0. So I found that 0 on my calculator, which is 1.2545447, whatever. And I left the cursor there, quit out of the graphing screen, and then I took x and stored it as a. Well, now on your piece of paper, you can say a is about 1.254544706. Well, now I get to rewrite this antiderivative as the opposite of the area from 0 to a, because that would be, or the signed area from 0 to a, because that would be negative, and then plus the area from a to 5 of v of t dt. So now I don't have to write 1.255 every time. I could just state that a equals that and then use a on my piece of paper. Now I did use the calculator for the rest of it, and I found that it was about 42.587 units, which does make sense. This little area under here would be 3.793. Of course, we're making that positive. And then this here is 38.793. And then I checked it with a quick overall absolute value of what I had typed into Y1. The now try problem is part C of number 1, so we're still back at this velocity curve of 5 cosine of t, and t is going to be between 0 and 2 pi, and part C wants us to find the total distance traveled by the particle. Well, if you notice, this part under here is negative, the area under here is negative, so we are going to find the absolute value of 5 cosine of t, the antiderivative of that, from 0 to 2 pi. Well, again, if I wanted to do this one actually by hand, no calculator whatsoever, I'm going to have to take the antiderivative from 0 to pi over 2. That's going to be positive area, so I don't have to worry about anything. But this is negative area, so there's a couple ways to do this. You could say that you're going to take the antiderivative then from 3 pi over 2 backwards to pi over 2. Remember, that makes it the opposite of what the signed area would be. And then, of course, we would still have the plus 3 pi over 2 to 2 pi at the end. Or that middle piece, that negative piece, could be written as the opposite of, so subtracting the area from pi over 2, signed area, from pi over 2 to 3 pi over 2. Either one would be acceptable as long as you make the middle signed area now positive. So now going by hand, the antiderivative of 5 cosine of t is 5 sine of t, so I'm going to evaluate that from 0 to pi over 2. Then I'm going to subtract from pi over 2 to 3 pi over 2. Then I'm going to add again from 3 pi over 2 to 2 pi. So if I use the fundamental theorem part 2, I plug in b and then plug in a for each one of these pieces. And I get, after some simplification, that should be 20 units. And of course you can check that on your calculator to make sure that that is in fact correct.